us today. And I think we have a terrific, absolutely terrific hour ahead of us. For those who don't know, maybe those who are not students, we have this course, first experimental course on data analysis for archaeologists. It's now not even fully official, but from next year it will be. And generally its aim is not just to learn some statistics, to make pretty plots, although it's also very important, but maybe to change the ways how we make argumentation in archaeology, because what this statistical methods gives us, it's not only the results, but they make us think very precise about our argumentation and how we prove our hypothesis, our theories. And well, I hope at least partly this was, at least on 10%, it was more understandable than before for the students at least. And now we are ending this course on 2 guest lectures on network analysis, and next Friday will be on Asian-based modeling. And I think this is absolutely great for us. And for me as well, that I'm outsourcing all this stuff to people who know it better. Yes, today we are happy to have Tom here. He is an associate professor at Orhus University. And he also has a book on network analysis. I shared it to our teams, but for those who are outside, just if you don't have it, go ahead, let me know, write me, and I will send it as well. Okay, we have a limited time, so I'm stopping, and the floor is yours.
Thank you so much, and thank you also for the invite. And it's a real pleasure to be able to talk to you. I hope it's okay if I do this in English. I mean, I don't think we have an alternative, really. It's going to be English. I can also do Dutch or Danish, but, you know, this might be our best bet here. As Alisa said, I'm an associate professor in Aarhus University, that's in Denmark. And what I've been doing my entire career, really, is telling archaeologists that network science is a thing, and that they should do much more of it. And if they want to do more of it, they should do it well. And so I've made those arguments, mostly working on the archaeology of the Roman Empire, and I'm particularly interested in mobility in the Roman Empire. That's why I'm going to use a lot of examples from the roads of the Roman Empire. But this research line has really gotten out of hand. I've developed tons and tons and tons of resources. One of these is this book that Alisa mentioned, and I'm going to use this also as a reference. And there's some really valuable online resources that are open access and free related to that, which can teach you everything I'm saying in practice using the programming language R for free. So that's awesome stuff. But there's more. Alisa shared with you a document of resources, which lists all of the conferences, communities, journals. But what I find particularly useful are free open tutorials that will teach you in practice how to make network science software work. So if after this hour, in which I will introduce to you what archaeological network research is, if after this hour you're still not deterred from learning more about this, then look at that document with resources. Try out one of these tutorials. Try to make it work. Try to play around with it. That's the best next step. Okay, I'm going to share my slides with you. And let's assume this is looking good.
Yeah.
Okay. So, the things I want to talk to you about, first of all, is what are the past relationships that network research tends to study? Why are we interested in relationships in the past? We also are interested in very diverse types of relationships in the past, and we use network research to study all of those. So I will give you lots and lots and lots of examples. The reason I do this is because I don't really know what precisely you are interested in. I tend to be interested in the archaeology of the Roman Empire, but I'm not going to assume that that's the case for everyone. So I want to show a lot of examples of different types of relationships that we've used network science to study. And then I will go into a little bit more detail about roads of the Roman Empire, because that's what I do specifically. And I want to kind of deconstruct things a little bit. I want to show you what could we use network data for to represent Roman roads. Why is that interesting? What kind of questions does it allow us to ask? And I'll show you a couple of results of the kind of things we can do when we represent roads as network data. And then finally, I'll talk you through that document of resources to recommend useful next steps. Okay, relationships. So network science is all about relationships. Relationships in the past and relationships in the present. As archaeologists and historians, we are interested in understanding how human behavior changed and how human behavior functioned in the past. But we don't do that directly. We can't see those people. Those people are dead. So what we use is written sources and in particular material culture sources to reconstruct that past human behavior and to understand human behavioral change. And so we're interested in absolutely everything about those humans in the past. But with network research, we're particularly interested in relationships. So there's tons of those kind of relationships that archaeologists tend to study. Relationships between individual people in the past or between communities that lived at archaeological sites or past settlements, spatial relationships between places, but even relationships between objects, because we have this massive focus on material culture as archaeologists. So I want to kind of give you a quick example of that using this paper here by Kanan and Mo, published in 2020. It's called The Roots of the Columbian Exchange, an Entanglement and Network Approach to Early Caribbean Encounter Transactions. And I'm using this paper because it does something extremely creative. It is using historical sources, the actual diaries of Christopher Columbus and his colleagues, describing their interactions with Amerindian societies that they met in these first encounters. But what the researchers do here is they focus on the material culture, how are particular objects, how are particular types of material culture represented in these diaries, in these textual sources, and how are they related to each other. The researchers are interested in understanding the relationships between these two different communities, the Europeans and the Amerindians, and how they get into contact, and how that's mediated through the material cultures, through the objects that they exchange. So let's have a quick look at that. There's no need to read all of this, and you'll get the slides. This is just a picture from that paper, but it represents here at the top an excerpt from a diary. So the diary says, for example, I gave red caps and glass beads, which they put on their chests, and many other things of small value. So there's objects here that are mentioned that the Europeans give to the Amerindians: red caps, glass beads, things of small value. And then on the other hand, there are objects that the Amerindians give to the Europeans. So there's, we were brought parrots and cotton thread in balls and javelins and many other things. And so we have a historical text here that describes interactions between individuals and communities that are extremely different, that are used to working with different types of material culture, and they exchange that material culture. This is a relationship that, as a historian or an archaeologist, you are interested in understanding, and you're interested in understanding it through the material culture. So network research could be used here to represent these relationships and to think through the objects and the relationships represented in a text, about those relationships that actually happened in the past, about the relationships between the Amerindians and the Europeans, about those exchange relationships. So what they've done here is represented every one of these object categories as a node, a dot, The circles represent Amerindian objects and the squares represent European objects, and they are linked by one of those lines, by a relationship, if they are exchanged together. So we can see, for example, that beads and bells are European objects that are very frequently exchanged together. And we see that belts and pendants are Amerindian objects that are very often traded together. These are things that we know, but there are some things that are less frequently mentioned in these sources that are more peripheral here that maybe surprise us, like molasses, mirrors, and cotton objects being exchanged together, and less frequently so with those things that we see at the center here. We don't need to tease this apart. This is not our research area, but I thought this was a good example of we are interested not in these objects or not in how those objects are represented, even in textual sources. We are interested in the European communities and the Amerindian communities. We are interested in how they got into contact, what their relationship was, how that was mediated through trade, through exchanges, through gift giving, and what the structure of that was. And network research can help us to represent our sources of those relationships. It can allow us to think through what were those relationships, what were the strong parts of the relationships, what were the weak parts of the relationships, what things were very frequent, what things were very rare. Okay, that was just an example to start with. You will notice that all of my slides have tons and tons and tons of text on it. That is because you have access to them and you can read them in your own time afterwards. So if there are things that you didn't follow very well or things where I don't have the time to explain it in detail, everything you need to know is on the slides, including links and references. So these are the kind of relationships that archaeologists are interested in. And some of these relationships are past relationships, like the interactions and exchanges of Amerindians and Europeans. But other relationships that we're interested in are more in the recent past, or are things that we do ourselves. For example, how do the archaeologists study the objects of Amerindians and of Europeans? Or how have we used network techniques, for example? Or how are we currently today coming together in this particular Teams meeting where information is exchanged from Scandinavia to Kiev, right? Those kind of relationships, they could affect the knowledge creation process about the past, and we might be interested in studying them. So there's relationships of the past and relationships of the present that archaeologists commonly study. Those relationships, we could call them relational phenomena. They're just stuff with relationships. If we are interested in studying relational phenomena in archaeology, then you do network research. That's what it's designed to do. There are massive books full of methods, theories, approaches. There's software that is purposely designed to allow you to study these kind of relationships. If you want to represent your theories about how relationships in the past functioned, network science has techniques for that. If you want to represent your data and the relationships in your database, network science has techniques for that. If you want to understand to what extent your observations, your archaeological or historical data, reflects relationships that match your relational theory about people in the past and how they interacted, then network science has hypothesis testing methods for that. So network research really is just the use of network methods and theories to study relational phenomena. And archaeologists study relational phenomena all the time. Okay, if you have questions, just unmute and raise your voice. It's no problem at all, to interrupt. So network research is not invented by archaeologists. It's actually been around for about a century now. Well, a little bit less so. The earliest examples are in sociology. At a time post-Second World War, when sociologists became more interested in explaining human behavior through the relationships between humans rather than exclusively based on the properties of individual humans, like For example, the age and the gender of a person, how does that affect their behavior? How does that condition their behavior, right? Well, it does, but the way in which this person knows this person also affects the behavior of that person. So sociologists became interested in that in the 50s and 60s and started developing formal methods drawn from a branch of mathematics called graph theory to represent their theories, to represent their observations, and to study it. And so social network analysis was born. Then the physicists came along in the late 90s, and they completely ignored, as physicists do, decades of development in sociology and just used graph theory to represent different relational phenomena. This was specifically associated with the rise of the World Wide Web and the digital availability of massive relational databases. You can see here Facebook profiles, for example, from 2010. So this is really history. These kind of data sets became available, and physicists started being interested in understanding the relationships and the patterning in these large databases. So they started doing lots of network science. Luckily, in the last 15 years or so, there's much more cross-fertilization between these communities. But I mentioned this little history of research because archaeologists started doing network research really only in the early 2000s. And so at that point, there were two big communities that we could draw influence from. The physicists on the one hand, who were interested in all types of networks, but especially big ones, and the sociologists on the other hand, who were interested in human social networks and especially small scale ones. And so we've adopted methods and theories from sociology and physics. And now, 2024, archaeological network research is totally a thing. There's a book called the Oxford Handbook of Archaeological Network Research with like 1 million chapters. And it represents a huge diversity of these kind of relational phenomena that archaeologists have used network science techniques to study. But it's really it all started about 24 years ago based on these two fields, more developed fields. Okay. Network research tends to use network data representations. Network data consists of a set of nodes. So that's jargon. Nodes is jargon for these dots. The dots, the units, the entities of research interest. Here I've got a little picture as an example. Let's say these are Roman roads, right? All of these lines are roads and all of these dots are settlements. So the nodes here are those squares and circles and little houses. That's our set of nodes. In network data, we need a second set of things. We need a set of edges. Edges is another piece of jargon. It's basically a word representing relationships or ties, the things that connect the nodes. So here in this example, we have a pair of Roman towns, and they are connected by an edge here. And that edge represents a Roman road going from node 1 to node 4. We can also have additional information about these nodes. For example, in this case, we know that these Roman settlements have different statuses. We see here that node 2 is a town, that node 3 is a colony, and that node 1 is a municipium. If we argue that relationships can affect the opportunities of these nodes, then, this might be interesting information to know. It might be relevant to know that some of these towns are colonies and some of these towns are municipia. And maybe the number of roads or where they're positioned in a road network could be affected by this status. We could also imagine that we have additional information about these edges, about these relationships. So we're looking at roads here. We know that some of these roads are short and some of these roads are long. That's additional information, the distance of these roads that we might have and then we might want to take into account in our studies. So network research is the use of network data to study relational phenomena. Network data consists of a set of nodes and a set of edges and additional information about the nodes and the edges. That's the basics. But you can apply that to 1 million different things that we observe in reality. On the right-hand side here, you can see a table which is taken from this book here. So that's the Cambridge Manual in Network Science in Archaeology. And I think in chapter 2, we give an overview of the diversity of phenomena that are studied by archaeologists and how you could represent different nodes and different edges. So there are material culture networks, movement networks, spatial proximity, visibility, food webs, co-authorship, museology, lots of different things. What I'd like to do now is give you a couple of examples from this. I'm going to go through that relatively quickly because the point really is not necessarily for you to grasp the details of those examples. The point is for you to see, oh yeah, Tom's not lying. You can totally apply this to lots of things. There's loads of relational phenomena. And also, I don't know what you're interested in, right? So perhaps one of these examples will really help you to make the click to see like, okay, that's what you mean with the relationship. And I can see that that's useful for archaeology, but not those things. And that's okay. If you're interested in any one of these, there are links and a literature for you to follow up on later. First of all, material culture co-occurrence. Now, this is a thing that archaeologists do all of the time. We go out to sites, we excavate at those sites, and we identify objects. Then we categorize those objects. We say, this is object type 1, this is object type 2, this is object type 3. And then we go to another site and we excavate there, and there we find some objects, and we see object type 2 and object type 3 and object type 4 are found at these sites. Now, what we very often do, and we can do this just descriptively, informally, using natural language, or we can do that using statistical techniques, but we compare these sites, right? We say, at this site, at site 1 and site 2, there's a couple of object types that were found at both of them. They co-occur. These two object types, type 2 and type 3, they co-occur at site 1 and site 2. And as archaeologists, we find that meaningful very often. It is very common to formulate the assumption as an archaeologist that if the material culture found at a pair of sites is similar, then perhaps there's some sort of meaning to the relationship between these places. Perhaps there was an exchange of goods, or perhaps there was a frequent interaction between these communities. Perhaps one community learned some material culture manufacturing techniques or decoration techniques from another community. Either way, the co-presence, the co-occurrence of material culture types reflects a relationship between these places that archaeologists are commonly interested in, commonly have theories about, opinions, and are interested in studying. Network research is very often used to study these kind of relationships, to explore object types that are found in multiple places and to see where that's the case and where that's not the case. How we do that is by making a network representation where, on the one hand, the sites represent nodes, and on the other hand, the object types also represent nodes. And then we connect sites with the object types that are found at those sites. So in this case, if you follow my cursor, you see that at site A, we have found object type 1 and object type 2. Whereas at site B, we have found object type 1, object type 2, and that's the same. So their assemblages are identical. Then we can make different types of networks to study either the relationships between the sites, and that's what you can see here on the left-hand side. These are relationships between the sites as mediated by material culture, co-occurrence, or we could represent relationships between the material culture types as mediated by the sites on which they are found. So for example, object type 4 and 3 have both been found 3 times together in 3 different sites. Lots of examples about that in the archaeological literature. Here's one example by Søren Sindbak. This is a really early one from early medieval Scandinavia, where we have 72 archaeological sites, and they're Viking Age sites. And they are connected to each other because one or more of 31 different material data types were found at both of these sites. And Søren Sindbak used this to study interactions between Viking Age emporia, between early trading places. Some of these places just had lots of things from absolutely everywhere. And they were considered to be more important emporia, kind of like hubs in a trade network. And other ones were more peripheral. They had maybe one non-local thing or two non-local things. They were of secondary importance. Okay. Another thing that we do very often as archaeologists is consider space. The location where these sites are, the location where objects are found, and the spatial proximity, the spatial relationships between all of these things, we find that important because it could reveal us something about human behavior of these communities that lived in these places and the people that deposited these objects. But a very pragmatic reason why we care about space is because very often it's the only thing we have. You know, the humans are dead, we excavate their trash, and then we just have to figure out what they were thinking. You know, that's insane. So it's also insane to throw away that additional information you have about the location. So archaeologists are great at using spatial methods or making the most out of spatial information related to material culture. So one of the things we do very often, for example, is explore how you could walk through a landscape from one place to another using the path of least resistance. So to minimize your energy expenditure in a landscape, which is one way of representing relationships between these places. And these kind of least cost paths could also be studied using network representations. Here's an example of mobility networks that are more based on empirical information. Well, there are less derived, that are more a representation of some sources. We're looking at the south of Spain, the Roman province of Bética, and we're looking here at the Guadalquivir River and its valley. All of these dots are places that are mentioned in historical sources that mention the ability to move from one place to another. The red lines here represent the Antonine itineraries. That are some fantastic resources that Roman archaeologists have access to that literally say, if you're a Roman and you want to go from Cordoba to Hispalis, present-day Sevilla, well, then you just take this road and you walk the Via Augusta. You go from this place to 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 this place, and then you're in Seville. Easy. Now you could represent that source as a network by representing every place as a dot and the ability to move from one place to another as an edge connecting those nodes. But we are in Roman archaeology, so obviously we have tons of resources. We have way more information than just this. There are something called the Ravenna cosmography, which does the same, and that's this yellow line. And we have something called the Vicarello goblets, which are blue lines somewhere in the background here. And we also have navigable rivers. The Guadalquivir River was navigable between Cordoba and Hispalis, and the Genil River was navigable between Écija and here. And you could just also move between these settlements on the rivers. So we have here a lot of different sources that tell us about a relational phenomena, the ability to move from one settlement to another. Network science here is used to represent them as a network, which allows us then to explore the structure of this network. Which were the places that were accessible via multiple of these means of transport? Which were the places that seemed to be central to the movement of goods, people, ideas, infectious disease throughout this area? And which were the places that were really hard to reach through these roads and rivers? I'm going to tell you lots more about roads later. Okay, this guy in the center here is Cicero. I'm showing him because actually one of the earliest examples of network research applied in classics was on this corpus of letters written and received by Cicero. And it's published in 1990 in a journal called Social Networks. So if you have letters, imagine that, right? If you're a historian and you have letters, you can represent the sender and the receiver of a letter as a node, and the sending of the letter as the edge. And then you get a social network of the past of people who were in correspondence with one another. They are sending letters to each other, which tells you something about the communication, the exchange of information. And sometimes, very rarely, you can even do this for classical antiquity. But if you're a historian, obviously you have way more data. So here's some good examples with some beautiful links. You can click and explore. These are websites that show you these actual like thousands of letters from 16th century England and people who were nobility mostly, who were sending letters to each other. And here's another visualization of a much bigger data set. Yeah. Also, if you want some like easy access literature on, you know, how are historians using networks, then this book is actually a good example of that. Tudor Networks of Power by Ruth Annert and Sebastian Annert. They're really kind of core to this community. They've done lots of fantastic work, and the book is extremely accessible and interesting. But very often as archaeologists, you don't have access to that kind of information. There are a few best case scenarios where you do have access to that information. And I kind of want to showcase this paper that we've published in the Journal of Historical Network Research. We were studying these tombs of elite individuals in Palmyra in the Syrian desert. And so this is archaeological information, right? Like typical Indiana Jones stuff. You go down in some unlit tomb, and then there's graves on the left and graves on the right, and there's corridors, and you need the torch to see anything. And there's lots of niches. And in every one of these niches, a member of one family was deposited. What's also great is that they literally made a portrait of every one of these people. So you can see what they looked like, what clothes they were, what jewelry they were. But what they also did is they chiseled some epigraphy, some inscriptions. They wrote, the name of this dead person is this. And by the way, if you want to know, his father was this, his wife was this name, he had 2 children, you know, his grandfather was this. Best case scenario archaeology, right? We can reconstruct genealogical networks that existed 2,000 years ago of actual individuals, men married to women, their grandparents, the number of children that they have for 5-6 generations spanning 200 years, right? That's amazing. We don't just do that using the historical sources. That would be cheating. We also, there's missing information in these historical sources that we try to make up for with the archaeological information. So, very rare best case example of the study of individual level social networks in archaeology. It is possible. Check out that paper. Okay, but sometimes we also use space for different things. So another thing that archaeologists are very interested in is what can you see in the landscape? Sometimes we find sites like things we call hill forts, for example, that are visually prominent, you know, settlements that are built on top of a hill, very inconvenient to get to. So we hypothesize that there must have been a reason why these places were on top of hills. And sometimes, if we don't have any other information, we theorize that it's because of what you could see. Perhaps from this hill settlement, you could visually control the surrounding landscape. You could see, you know, resource extraction areas. You could control neighboring villages. Or perhaps from this settlement, you could send a visual signal using flags, smoke, or fire to another settlement that was visually prominent. It could function as a visual signaling network. So again, this has been studied very frequently using network research. Here's an example of a study that I did a couple of years ago in the Himalayas in India, where there are like, you know, hundreds of forts that are visually interconnected. And so you could represent those sites as nodes in a network. Then you use GIS to identify visible lines of sight from one settlement to another settlement. And then you could represent those lines of sight as edges in a network and study it. In this case, we were able to identify that it is feasible that this system functioned as a visual signaling network. So if there was aggression in the east, then that information could be transferred effectively using visual signals from the east to the west over a massive area. Lots more examples. Okay, now I want to conclude this set of examples with some of these like present day cases. I argued that sometimes as archaeologists, we're also interested in turning the camera on ourselves. How have archaeologists in the past and in the present constructed these narratives of the past? How have we constructed our knowledge about human behavior? How do we write the big history books, right? This is not just through observation. It's also through nepotism. It's through influence. It's through differential ability to contribute to the knowledge creation process. And there's relational aspects here, right? If you're an archaeologist and you're married to another archaeologist and you're both active in writing the narrative, that relationship matters. You're not going to massively disagree with your partner in writing, right? If you are an archaeologist and you're working at the same institution as an archaeologist, as another archaeologist, then perhaps you're going to have more similar or perhaps extremely different views. But there's a relationship here of sharing an educational institution that matters, that affects the knowledge creation process. Or even more trivial, right? Like you're an archaeologist and you go to a particular site and you go and excavate that site with another bunch of archaeologists. There are certain ways of talking about the material culture that you excavate, certain ways of writing the reports. The knowledge creation process will be shaped by the actual people you meet at that excavation and the way in which you talk about it, formally, as it's written in the reports, or informally. But the narrative will change. So you can also use network research to explore that. And Alison Mikkel has written a really great paper about that for the case of Çatalhöyük, where they actually recorded these digital diaries of excavators and how they wrote on a daily about the things that they excavated, the interactions that they have from a personal perspective. So here we have, these individual diaries and the people who wrote them and the words that they used to describe the actions that they did, the things that they excavated, the things that they found, right? So check out that paper by Alison Mikkel in Journal of Archaeological Method and Theory if you're interested in that. There's also a good chapter on knowledge networks in this Handbook of Archaeological Network Research, which, if you're interested in that, then that's a good starting point. Okay, another case is where we study how archaeologists formalize influence in the form of citation. So when you write a paper, you say, I've used this source and this source and this source and this source, which is a way of formally saying I have been influenced in this knowledge creation process by these sources. That's relational information, right? Your paper is related to all of the papers in your bibliography. If you do that for the entire discipline of archaeology, you can create kind of a knowledge graph, right? Of how similar certain papers are based on their influence and how dissimilar they are. If you want to explore that in an interactive way, click on that link to get you to this paper by Sinclair from 2016, who has done that for the field of archaeology. Okay. Are there any questions so far? No. Then let's talk about the Romans. So I am a Roman archaeologist. Most of my career, I spent writing books like this, telling archaeologists, use networks, it's good for you. But I also apply this in substantive cases, in cases where I argue there's a relational phenomenon here in the Roman Empire that I'm interested in understanding, and network science is the right method to study this Roman past phenomenon. What I've invested the last 4 years of my life in is understanding terrestrial mobility as a relational phenomenon in the Roman Empire. How were landlocked places in the Roman Empire connected to each other via road infrastructure? How did people move from one Roman town to another Roman town? You would think like, well, that's really easy to study because it's about Roman roads. We know where the Roman roads are. We've been studying Roman roads for hundreds of years. It turns out that we have been studying it, but we have not been digitizing it. There's tons of detailed information about excavations, regional surveys, or historical sources like the ones I showed you earlier, which have simply not been digitized and aggregated. So we spent the last 3 years digitizing and aggregating all of that information to create the first spatially detailed and open digital representation of all roads of the Roman Empire. This picture, you're one of the first people to see it. And this is just to show you that this is, a collaboration with lots of people who are specialists on different areas. But we can study, if you have all of the roads of the Roman Empire, you can study massive phenomenon. You can study terrestrial mobility on a continental scale. And we can use a lot of methods for that. We can use statistical methods, GIS methods. But for some questions, when we argue that the relationships matter in specific ways, we can use network methods. So how do you do that? Well, we do what I said earlier. We create a set of nodes, and those nodes, in this case, they could represent towns, but you could also argue that they should represent crossroads, for example, the ability to transit from one road to another road. Or they could represent bridges, which might be places where you can also transit from a road to a river. Either way, you have a set of nodes, and they are connected by a set of edges, which represent those roads. And then you have additional information about those things. What can we do if we represent the roads of the Roman Empire as network data? Well, we can say things at lots of different scales. I'm going to say a couple of things now with this slide, and then I'm going to show you these things. So first of all, we could identify some general structure in the entire Roman Empire. We could identify differences in the structure of the network throughout different regions. For example, some regions have a very hierarchical way of structuring mobility of people overland, and other places more distributed. I'll just show you what I mean. You know what, I'm just going to share my desktop. And then I can just show you what I mean. That's this one. Okay, you should be able to see my desktop now.
Yes.
And so this is our interface for all of the roads of the Roman Empire. Every line here is a road, and every source, if you click on a line segment, you have additional information about them. And you see this is a main road. What we also do, which is very useful, is we say, this is not certain, this is not observed, this is conjectured. There are some sources that suggest there's a road here, but it's not physically identified, so it's uncertain. And then we have additional information about it, such as the bibliography based on which it was digitized, and it has a unique resource identifier, which means you can give this link to someone, and you can cite this link, it's stable, and this allows this road to be linked to other resources. For example, we are linked to Pleiades, the gazetteer of ancient places. But what can you do with this kind of network data? Well, I was telling you, you can, at a very large scale, see differences throughout this, the way in which transport is structured. We could look here at Egypt, for example. And you can see that it's not distributed. There is like a central vein here. There's a very hierarchical system. Everything, you know, there's deserts on either side of the Nile, and all of the roads from Red Sea ports, for example, or from desert oases go to the Nile. And then the Nile leads to the Mediterranean. It's a very hierarchical structure of this regional road network, which you can represent using numbers with network science techniques. And then you can compare that with other places. Let's look at modern day France, that's ancient Gaul. And you can see here all of these star-shaped structures, right? This is a very distributed system. It's not like there's the Rhone and Saône Valley, which dominates everything and everything goes to that. No, like you can go from one place to 10 other places. And then you go to a next place, you can go to 10 other places. And then you go to the next place, you go to 10 other places. It's more like, you know, a triangulated mesh throughout the entire region. It's much more distributed. Now, you know, we knew those things in general, but we've never been able to identify them formally and compare them in any detail. Another thing we can do is say, well, how do you get from one place to another, right? Like a GPS. A GPS in your car or Google Maps, they use network data, right? Where places or crossroads are nodes and the edges are the roads connecting them. And so if you have a network data, you can ask questions like, how do I get from, let's do this, if I click here, from this place called Madauros, and we'll go to somewhere in Syria, Apamea. I click on that. Then you see a red road here. So this is how you get from there to there. You can see there's a lot of transit here over secondary and main roads. You can also see how long it takes if you take a donkey. So this is 3,700 kilometers, and it will take you 830 hours. So general patterns of mobility in the entire empire. Imagine this is a path, right? A path from one place to another. But there are millions of places in the Roman Empire. Imagine if you calculate a path from every one of these places to every one of these other places. It's like a representation of all possible mobility throughout the Roman Empire. You can do that, and we've done that. And then you see stuff like this. And I hope you can see my slide here. What we're looking at here is we've calculated from everywhere to everywhere over the network, all possible paths. And then you can see that some paths, and they're highlighted here in green and yellow, some paths are more frequently transited. So there is, in all possible transport, these ones are traveled over more frequently. More paths go over these ones than over any other ones. So these are general patterns of the empire as a whole, of how mobility might be structured or funneled through particular pieces of infrastructure and away from other pieces of infrastructure. And obviously this is massively conditioned by space, right? By geography. Now, let me just highlight that no one does that, right? No one travels from whatever it was, from Gibraltar to Morocco overland on a donkey. People don't do that. People didn't do it in the past. People don't do it in the present. We're talking about the Mediterranean here. Over long distances, you take a boat. But these roads still matter at a different scale. If you zoom in on many of these places in the Roman Empire, many places are landlocked. They are not reachable by seas. They are not reachable by rivers. The vast majority of people in the Roman Empire lived in the countryside, not in cities, and they lived in small places. Lots of people were peasants, small hold farmers, not even in villas, right? How did these people get to the nearest city? How did they get to the nearest seaport? They used roads. They didn't have an alternative. So for landlocked places, which is the majority of places, and to connect them and for mobility in landlocked places, roads matter. So these kind of queries are very interesting when you're connecting places like Gerasa, that's ancient Jerash, to a major seaport like Caesarea Maritima, right? And if you take a donkey in ancient Palestine, it would take you 41 hours, right? So you can ask questions on this smaller scale, right? Like, how was mobility structured in this region? What were the opportunities for people in this landlocked place to reach the nearest larger settlement where they could sell their goods? What was the opportunity for these people to be reached by goods that came from very far away because of their distance to a maritime port? Another thing we could explore is the particular position of every one of these settlements. How many roads are connecting Jerash to the rest of this region? And is that a lot of roads, or is it relatively few roads? Jerash here seems to be a bit of an intersection of 4 important roads, whereas other settlements might be more positioned just along one road, right? Like might be just like a place like this one along a road. This gives different opportunities to these places. From Jerash or from Philadelphia, you're able to go in many different places. You're closer to many other places. Whereas this place, it's an important intermediary between Jericho here and Esbus. But aside from that, you're pretty much stuck, right? There's not a lot of opportunities here. So network science provides you with techniques to represent these different opportunities, to derive metrics like the number of links of a node, the number of roads a settlement is connected to, and to link that to your theory. What does it mean that Jerash has 4 roads? What opportunities did it provide? Is that in line with my theory, or is it not in line with, is this a surprise, right? Okay. You can also derive metrics like that for the entire data set. So here we're looking at the number of roads that are connected to every settlement, but we're only showing the settlements that have very many connections related to them. And then we see here in France, for example, there's a lot of settlements that have a lot of roads related to them. And that's in part because of the constraints that space provides. And in France here, we saw this distributed system. There are a lot of places which can be reached by a lot of other places, and that's just not the case in other places. So as a Roman archaeologist, I'm interested in these kind of patterns. I'm interested in knowing which are the settlements that have a lot of connections and which are the settlements that are more peripheral on this road system. Now, finally, I want to tell you why this is interesting. I'm going to just show my slides like this now, okay? Because I want to switch also between my browser. On the one hand, you know, as archaeologists, sometimes we just want to do stuff because we can. Why make a network of all the Roman roads? Well, just because I can. I've digitized all the Roman roads. I will make a network out of it. I will study it. And that's okay. You can explore your data set and you can explore and see how it helps you think through these past relationships and how it maybe could help you generate theories or ideas or lead you to observations that you might have missed out. That's okay. But really in science, it's always good to start with a theory and to create an experiment and to try to falsify your theory. To try to say, well, if I perform this experiment, I can say that my theory is a bad theory or my theory is a good theory. There's some plausibility to it. So in archaeological network research, we do that by formulating dependency assumptions. These are basically our theories about why relationships matter. Why are relationships important for this road? Well, it's because of this theory, right? I'm not going to explain this in detail, but if you want to know more about dependency assumptions, really the theory behind archaeological network research, I've got all of the slides for you here. And read the book. But I'll just give you an example of this for the case of Roman roads. Why does the position of a town on a road, like I've shown you earlier, why does it matter? Well, because these relationships, if they are in particular shapes, they will affect the opportunities of the towns. Let's look at this example here. We have town A, which is connected by a road to town B, which is connected by a road to town C. Now, these towns do not have equal positions on this network. Town A is at the end and town C is at another end. And in between, there is town B. So because of the way in which these relationships are positioned, the towns have different opportunities. Town B here is the only town that has the opportunity to levy a tax on all of the movement of people and goods between town A and town C. And it's because of its position on these roads as an intermediary that it's able to levy a tax. Town A and town C do not have that opportunity. Town A and town C do not have the opportunity to control the flow of people and goods if the relationships are like this. So here's an example of a dependency assumption. Relationships matter because they affect the opportunities of the nodes and how they're positioned, of what these communities in these towns could actually do. Let me give you a final example. Imagine if the people in town A and town C said, I am so sick of these people in town B constantly levying a tax on all of our movement between us two towns. I'm sick of this. Let's invest our money instead in building a new road. Let's make some new infrastructure. We're making a direct road between town A and town C. So we're going from this system here to this system. Now you can see, first of all, that the opportunities are changed, right? Town B no longer has the opportunity to levy that tax. Everyone has an equal opportunity to be intermediary in exchanges in this new system. But you can also see another thing. These relationships gave rise to this relationship. It's because there was inequality first, which was generated by the roads being structured like this, that town A and town C decided, let's build a new road. So here, relationships matter because the existence of some relationships could create other relationships. My theory specifies that if you see these relationships, then this relationship will be created. That's an archaeological theory, right? If in an earlier period there is inequality in the opportunities of towns on the Roman road network, then in a later period, new roads will be created to rectify this inequality. This is a theory. This is an archaeological theory. Network science can be used to represent that theory, right? I'm using dots and lines to tell you now that I've represented my theory like this. This is my archaeological theory. Network science can also be used to study the implications of your theory. I can study how many roads connect this town as compared to this town. I can use a metric to express, using numbers, how central this place is as compared to this place. And then I can create an experiment that compares my expectations against my observations. So network science can help you to test your relational theories about the past. Okay, that's it. That was the hard bit. Now, I'm just going to show you two more slides. After this lecture, I very much recommend you spend 10 minutes playing around with these examples. So these are kind of online, interactive, playable explanations of how network science works. They have nothing to do with archaeology. And you can just kind of play with drawing lines between nodes, but they are designed to force you to think through, why do relationships matter here? What are the effects of creating this line instead of this line? So it's a good exercise and it's fun and interactive to kind of anchor your understanding of what network science is. If you're still not dissuaded, then join us. Network science is totally a thing in archaeology and history, and there are lots of communities interested in it. First of all, a go-to would be these two books that I'm showing there, right? This book is a manual which teaches you exactly how to do network science in archaeology. What I also want to highlight is that it's associated with an online companion, book.archnetworks.net. You have the link in the resources file, where you have everything for free. And so basically everything we say in the book is shown here in code. So all of the data sets that we use in the book, you can download them here. There are R codes. There's R code here that you can just copy and paste to then visualize a network. every picture that we show in the book is replicated here online for free. Every technique that we are trying to teach you in the book, there's code that you could copy, paste, and apply yourself, right? So this is designed as really a set of practical lectures to teach you yourself at home how to install R, how to download the data sets, how to get the right packages, how to learn network science yourself. So it's a good starting point. Well, it's and it's pretty advanced. It's a good place to continue. Then to get inspiration on how to link all of this network stuff to your own research, check out this book, because this book has 50 chapters or 45 chapters or something, and every possible kind of phenomenon that archaeology are interested in, there's a network version about it there. So that's a good place to kind of like get inspiration. Then finally, we organize an annual summer school in Barcelona where we teach network science for archaeologists and historians in practice over 4 days. And it's very cheap and very sunny. So check that out. We will launch a call next week, I think. Then there are lots of communities where you can learn more about network research, but you can also present your work. And these are communities that are really open to also just work in progress, right? Like most people present stuff where they're not sure, is this the right thing to do? Am I doing this right? You know, those communities are the Connected Past and the Historical Network Research Conference. So check out those links. Then these are journals that are dedicated to network research in history and archaeology. And then this is particularly relevant here. Just check out all of these links for practical tutorials designed by archaeologists and historians to teach you network research and a bit about software. Okay, I think that's it for me. Let's have some questions.
Yes, there is a question. You can already talk.
Hello, I'm Daria Morozova, Kyiv-Mogila Academy and University of Exeter presently. I'd like to thank you very much. Your lecture is very precious for me, both the methodology and your examples, because I'm now doing research about the connections, cultural and religious connections between Syria and post-Roman Britain. Antioch on one end and Cornwall or Devon on the other hand. It's more about maritime connections, I believe, but it's interesting if I could apply this methodology to my research. And the main difficulty in this case is that it's where is Syria and where is Britain? There are few data, so I have to use different kinds of data, personal connections, trading connections, whatever. Is it possible to work with all of them, or should it be different, a number of different researches? How do you see it?
Yeah, okay, I'm just gonna get a book. So there is quite a lot of work in archaeology and history on networks and religion. I can't write anything in the chat here. I recommend the work by Anna Kollar, Collar. And by the way, just send me an email and I will send you all the literature. But she studied cults in the Roman Empire. And also she published this edited volume here, which is full of examples of the spread of religion. But just send me an email, that might be easiest. Also, in terms of maritime networks, I recommend the work by Justin Leidwanger. But about your question of how to proceed, right? My recommendation really is, you know, on the one hand, the past was complex, and the sources that we use to understand that complexity are diverse and complicated. But the way in which we study that complexity of the past using that complicated data is not by using a complicated method. It's by creating very simple but revealing experiments. So I recommend always to take one data source, one data type, for example, inscriptions related to a particular cult or something, right? And be very explicit about your theories of how that particular data type reveals aspect of that past phenomenon. So how do inscriptions about the cult teach us, and relationships in it maybe, teach us about that past phenomenon? And then represent that, explore that, maybe test something, right? And get some results and interpret that on its own level. And then you do the same with another source, right? So it's important that we have multiple different data types. I always want to treat them individually because as an archaeologist, I want to stay critical to the limitations of those sources. I want to generate experiments that are designed to really respect those sources. And then at some point, I merge them all, not necessarily formally, because that's really hard to do, but in my interpretation, right? This data type tells me this about the networks. This data type tells me this about the networks. This one tells me this. And I create a really rich interpretative narrative that helps me get to the complexity of the past. So keep it simple.
Thank you very much. Excuse me, how can we get all those links and materials that you showed us?
So I've sent them in the chat right now, but it should be there, at least those materials, these resources. But just in case, you can also write me or I think Tom, and I can send you the emails later. After the lecture or now.
Okay, so I will write.
That'd be great. I'm looking forward to seeing your email.
Thank you.
Tom, good morning. First, many thanks for your for each piece of very valuable information. And I have one question. Could you advise me, please, how do you calculate the time needed to move from one point to another? Are your assessment based on contemporary experimental estimates or on the information from written sources, like the speed of Roman legion on Mars or so on?
Thank you. So for our particular case, you can do multiple things, and we've done multiple things. Let me just first of all specify that our research didn't focus on calculating those times particularly correctly, right? Our sources, I mean, we focused on digitization, but there are plenty of people who have used all of the possible historical sources and people who have used a lot of experimental present-day information to say these means of transport, like a donkey, a cart, or a horse, they go so fast and they are affected by topography in this way. For example, the cart can't go, the ox cart can't go over 8 degrees or something like a certain number of degrees angle. It's unable to go. What we did in this case is just to use one particular source and then to use the values from that source. So here our ox cart goes 2 kilometers an hour. This is assuming an ox with a cart full of stuff. And a pack animal goes 4.5 kilometers an hour. Then another thing we've done is for the maritime, right? We have these connections here. This is something that we've implemented, but you can only really work with when we launch another version of our tool. You can see all of these maritime connections. And here, other variables are important to determine speed and the path taken and stuff. We're talking about the technology of the ship and also the currents and the winds. We've worked with David Gull, who has used a simulation technique to represent these 3 things and to simulate the path a ship takes from one port to another. But you've seen a lot of these studies using least cost paths, and they tend to average wind information per month. What David Gull did instead is take a data set of 15 years of wind data at a resolution of 1 hour. So every hour the wind changes. And so a sailor obviously doesn't sail on averaged winds. A sailor sails and makes decisions based on what the wind is right now. So if the sailing takes more than an hour, the sailor will change their behavior, right? And that's what his method represents. A sailor starts sailing, checks the wind, and decides to change their course. Checks the wind, decides to change their course. This introduces a lot of randomness, a lot of diversity in the results. So he ran every experiment 1,000 times. And all of that data is openly available on his repository here. Here you can download all of the simulation results and all of the parameter settings per route. And so we've used that data in collaboration with him to derive travel times over sea. Another thing we've done, and this is super new, is we've calculated least cost paths for every road. We're talking about hundreds, maybe 30,000 little segments. Basically, it's a lot of roads, you know, and we've calculated the least cost paths for all of them. And so we've used that as another estimate of energy expenditure, which the least cost paths are good at representing, and then their implications for time and distance, three-dimensional distance. This is not added yet, but this answer, I guess, reflects a couple of ways of approaching this.
Amazing. Thank you so much.
Alexander, you can talk, I think.
Thank you very much for your so inspiring talk. My question to you is, what do you think are the limitations of network analysis in archaeology?
Thank you. Good question. Super on topic. I appreciate it. Network research is it's a method. Network data representations in particular should be treated as a method with its strengths and weaknesses like every other method in archaeology. What I'm rather passionate about is not to push the blame of the weaknesses onto the method, but rather keep it within archaeology. So we are archaeologists, and it's our responsibility to do critical archaeology. That requires us to do critical theory and critical data, right? We understand our data, we understand what it can tell us, we understand where its weaknesses are, what it cannot tell us. We understand how to be critical towards the use of our data. The same for our theories, right? We come up with lots of different theories, but we understand where they're weak, we understand where they're complex, we understand what aspects there are to our theories. We should do the same with our methods, of course. We should use methods that are appropriate because they are able to represent the theory and an aspect of the theory that is representable. And they are able to use the data to test the theory or to explore the data whilst respecting the limitations of that data. So at every point in which we use network research, we should remain archaeologists. We should keep on thinking, am I able to do this? What's the most appropriate technique I'm using here? What's the most appropriate software? What's the most appropriate representation? Because it's archaeologically meaningful and because it's archaeologically defendable. That's a general answer to my approach to method in archaeology. More specifically, network research is designed to study relational phenomena if you can answer the question, do relationships matter? So if you are working in a research context like my own, and I can say relationships matter in this way because they affect the opportunities of Roman towns, or they affect the creation of new roads, then it's network science is appropriate. This also means the opposite, right? One of the weaknesses of network research is that sure, you can apply it to whatever you want. You can make a network of absolutely everything. But if you don't have an argument for why the relationships matter, then you're just doing it because you can. You know, it doesn't really add anything. You do need to have that that aspect.
So the later part of your reply is about weaknesses of theories. Did I catch it well?
Yeah.
Thank
So I mean, you know, you need good and critical theory. You know, it's very common as archaeologists to just kind of like use a method because we can, and to represent some stuff and to push some buttons and stuff. And that's okay. It's okay to explore, no? But these methods are so powerful if you are explicit about your theory. We can really like explore whether there's our ideas about how Romans interacted and what the opportunities of Roman settlements were. We can say something about how good those ideas are and how much they should really weigh in to the creation of the narrative about the history of the Roman Empire. And that requires us to be explicit about our theory, also when we're using computers. So.
Thank you very much.
Thank you.
Any more questions? I'll just, on a second, I will switch to Ukrainian. Про всяк випадок, якщо у вас є питання якісь, але ви не можете так, можливо, хтось зі студентів сформулювати їх англійською, то просто можете сказати, я спробую перекласти.
Пробачте, технічне питання. Чи це тільки у мене не завантажується просто чат? Чи у всіх, я не знаю?
Так, just yes, I'm returning to English. The question regarding the chat, I discovered now that I think that those who are outside of our teams cannot access this chat, and just unfortunately, sorry for that. But I will maybe provide my email and I can send it to you later. Yes, we will try to fix this next time for the next lecture. Yes, so any more questions? Because I have a couple, but I will wait for you. Okay, you can think about that, then I can proceed with mine. So maybe first one more specific about the roads. I just thought that really this examples with the Roman roads is quite unique because you have, in regard to spatial relationship, you have exactly the places and you have very explicit spatial these edges, and this is quite rare. For example, you don't need to hypothesize these roads based on watersheds or these places, but I was generally interested. So when you see them, are the roads always logical? You know, are they rationally located? So, for example, they follow this least cost route of the landscape. So they follow this kind of landscape features that allows them to be, or not. Or for example, there could be some places where you're just surprised that there is the road, why they did it there. So I'm generally interested. So for example, if we really work in the territory of this Pontic territory and try to restructure some places, some movements, we follow this kind of proposition that they probably will follow the most rational route. Is it always so when you have these examples?
No, they don't. So one of the things we are doing right now is to compare our kind of empirically informed digitizations of all of the roads with one model, which is a least cost path from everywhere to everywhere. And so this represents kind of one representation of logical, right? Like a path that minimizes energy, right? And I can tell you that there's lots of deviations. Another thing that I want to show you, it's a very low resolution, but another thing we've done is a thing that people say all the time about Roman roads is that they're logical in a sense that they are the straight line between two places. Roman roads are straight. Well, they're not. So we've calculated the sinuosity, which is the the degree to which it's like, you know, bendy rather than straight. And so obviously it differs. There are areas like Belgium, the Netherlands, and northern France, where obviously geography, or in the UK, where geography is slightly less of a deterrent for making straight roads. The same in the Po Valley, for example. And also, you know, where maybe some of the areas the digitization is a bit less good. But really, these are areas where it's fair to say that the roads are straight and they're logical in that sense. But in the vast majority of the empire, that's not the case at all. You know, roads are roads, and it's not because they're Romans that they could ignore the fact that there's a mountain in front of you, you know? If there's a mountain, you follow the pass. If there's a river, you follow that river. If there's a large settlement, you go to that settlement, but not at all costs. If there is a prior road, you follow that prior road, because that's the road that humans take, right? There are this kind of narrative is mostly based on like historical sources and the influence of the military and particular big infrastructure investments. In some cases, Romans built straight roads. And it's really annoying that the Via Appia in Rome, which looks very straight when you start walking it, you know, it's kind of like the best example and the iconical example of Roman roads. But this is not a representative case of Roman roads. Roman roads were not paved. They did not have cypress trees next to it. And they were not all in the sun. In the desert, Roman roads were camel paths, wide and informal and more dotted by way stations than they were by actual pavement. Most roads were dirt roads. Every place, every villa, every peasant farm, every town was connected by dirt tracks because you needed to get there somewhere. They weren't paved. Anyway, so some of them are logical, others are not, but in general, they are as illogical as everything else humans do.
Thank you. Yeah, so another question, I think more general ones about methodology. Well, how, for example, if you want to now do some network research in archaeology, how high is this threshold of knowledge you need to achieve? So, for example, I think some people could be interested, but afraid that maybe it's too much of the math is there. So it's I need to study a lot before I even do something. So what do you need, some prerequisites that you need to know, or from which place to start? And maybe some instruments for that.
Yeah, it's a great question. And so I'm just going to show resources. So the threshold is lower than it has ever been because there are tons of resources now. You don't need to know maths. I mean, let's not forget we are archaeologists and we're trying to do archaeological network research, right? So one requirement really is to be a kick-ass archaeologist. You need to be good at archaeology. You need to understand how you can get at a data set, how you can work with it, what's bad about the data. You need to be able to do archaeological literature reviews and identify theories and identify how bad theories are and how good theories are. And you need to be able to have that archaeological imagination that allows you to bring the dead objects to the dead people, right? That is important. But you don't need to know any maths because we are doing applied network science. We're not developing the techniques. We're using techniques other people have developed, and there are resources that tell you exactly what they do, and they guide you into understanding what the appropriate technique is. Really, I very much recommend using the resources that are out there. I recommend starting with one of these kind of games to kind of see, you know, what are dots and lines? What are the implications of changing dots, of changing lines? That really gives you a better understanding of what network science is all about. And then when you've decided to continue, I recommend you do a practical tutorial. In these resources, there are lots of them. And they tend to be standalone. They tell you everything you need to know to complete a tutorial. And in about 2 hours, you will have created a network and you will have the feeling like, okay, I can use network science software now. And that that experience is going to dispel like 90% of the imposter syndrome, right? Because you can genuinely learn how to do it in 2 hours. You just haven't done it now, so you feel it's complicated. And it looks great when I show it, but like, you know, not something you can do, right? Like, well, just sit through a tutorial, do it yourself, download some software, click on some buttons, and you'll create a network. You can totally do that. Now, there is a difference between being able to do a thing and being able to do it well, such that it generates new information about the past that is publishable, right? And that's the same with absolutely everything. Then there's a period of specialization and exploration. That is why we have the book. This is a manual. This is a textbook. If you want to learn GIS, you read the GIS manual, you do GIS. You want to do network research? Read the textbook. It tells you step by step what you need to do. It defines absolutely everything. It helps you in that thinking process of what's a good research question? Why do relationships matter? How should I stay critical? How can I adopt the right metric? And then it helps you in creating an actual practical example. For example, using these online resources, right? I mean, if you are not familiar with R or programming languages, this is not where you start. You try some of the other tutorials that use kind of click and point and click software. But if you want to go a bit further, then, this online resource, it really tells you everything you need to know, and it is step by step. So even if you don't have any experience with it, this is going to take a little bit longer to get into, but it's possible. It's totally possible. Yeah. And everything you need to do, you need to know is in there. You also don't need to be able to program. You need to be able to copy and paste. And now with stuff like ChatGPT, this is easier than ever, right? You just you learn, you follow these tutorials, and then you say, I want to make this kind of picture. Then you just go here and you copy and paste these things. You paste it into your own thing and you try to make it work. If it doesn't work, you ask ChatGPT. If it still doesn't work, ask someone who can code, right? But, you don't need to know how to solve all these problems yourself. And all of the resources are there to help you to do it.
Thank you very much. So more questions? Okay, so I think really this was just an enlightening lecture for us, and I personally enjoyed it very much. And well, I think everyone, and just in case, once again, about this problem with the chat, you can write, who doesn't have an access, you can write to our either Facebook or Instagram whenever you found this link, just to our department. So I won't try to now explain my email address. So just write to us and give your email address, and I can send these resources that I get, and also kind of give the email of Tom if you need some more information. So great. Thank you, and thank you everyone, and I hope to see you in a week on our next lecture.
Bye-bye. Thank you so much for today, and enjoy Isa's lecture next week. See you all.